For me, this could be an excursion. This could just be the natural play. We're talking about eons of things, and no one's even saying that magnetic reversal is a very cyclical thing. That's a kind of a hard thing to throw. But we do know, even with excursions, the disjointed poles that we have right now would say that we're at least headed into that moment, and that alone has enough of an effect on our climate and biology that awareness does need to be brought up. And any way that happens is good by me. So.
Continuing our March 20th edition of The Electric View, we have Todd Cleckner showing what his work, website, and applications are, and what potential they hold for the future of citizen science.
So my whole thing, my scope is sun to earth, and then the further out you go, the less I'm paying attention, I guess. And to me, it seems Bendo's is doing a lot of looking into deep space observations and really kind of the reflection of dark matter. So watching some of that, it seems to me that it's in the interpretation of the data we have. So I've always seen a huge potential to go back and look at post data, data that's already in the banks, and reinterpret it through these new lenses where we're giving the electrical forces a little bit more strength, or including them in the models if they're missing. Pulling back on gravity and playing around with the parameters a little bit, and we might see more and more structures like this. And that's kind of what I'm seeing more and more. Is that, especially when we start overlaying energy wavelengths,
right?
You really start seeing structures that are very reminiscent of toroids, Berkeley currents.
Right.
I'm curious how much this has to do with gravitational lensing and the actual lenses being the bending of seeing a Birkeland current on the side. Because I've never really, what do you think about that?
I think there's a lot of assumptions we're putting into physics that when we start going into deep space that I just don't know if we can do.
Well, do you use gravitational lensing when you go observing deep in space?
Personally, I don't do that.
I find the term itself like problematic to use it.
Sure.
Use a common parlance.
Well, that's how they started discovering the map for dark matter and dark energy, which gave us the view of it looking like diffusion limited aggregation across space, with having the node and filament-like structure it does by mapping these gravitational lenses and these pinch points, I guess you could call them as well. They would just be looking at a Birkeland current, and that could be what's bending the matter. See what I'm saying?
Not right off the bat.
Well, I guess if you look into gravitational lensing and the effects of what it is, and then what dark matter is and how they explain it, then you'll understand what they're explaining is Birkeland currents. Then you look into how gravitational lensing affects Birkeland currents and what they have to do with each other. See what I'm saying?
So what you're saying is taking the term gravitational lensing and like saying that those observations that are attributed to that are actually attributed to
Birkeland currents.
What we're calling Birkeland currents at this point. Yeah.
Yes.
Right.
Yeah.
Okay.
Electromagnetic lensing.
Do you guys
Yeah,
think that
magnetic
at some
lensing.
point, do you think at some point in time that we'll get enough information and data to differentiate between these types of currents, like subsect them, not just like into groups of Birkeland currents, not just all Birkeland currents?
Well, like Bruce was talking about, when you get into the deep space, they're entangled black hole systems, which are just ultimately inductive currents that are leading each other, which are Birkeland currents. So, I mean,
what I'm saying, I guess, though, is yes, like the homogeneous group, the big dome group of Birkeland currents. But then once we start to understand them better in their own subsections, delineate them per subsection so that we have a better understanding of the specific current for its specific purpose, for a specific place and job that it functions within. Because right now it's just this big, broad Birkeland current, right? And Birkeland currents run through everything, exactly like you're saying. But when we start to understand them better in their little parts, do you guys think that there is that differentiating them in this way would benefit the understanding of their function within their particular sciences?
I think that in biology, they're collagen. Collagen is a 3-strand helice that binds everything together. And then you have DNA, that's helicity and bound through helical processes, or the structure of it anyway. And then you have electricity, and electricity fractates in that type of manner, I believe, too. And that goes on all scales. And we call it different things. It's just the same thing.
Right.
With different names.
Todd, this image has come up. This pot is all over the place. Is this conceptual for the most part, or would you say that there's data associated with this that's pretty solid?
Interplanetary magnetic field, yeah. It's decent. It is a model. We really don't have the probes to know exactly the shape. So, I mean, anything when you see space plasma represented like that, it's idealized.
Mm-hmm. Sure, of course, yeah.
But yeah, no, we see the flux. The flux is very real, and we go in it and we go out of it really quick. There's some speculation if that might be a possible trigger or a sometimes trigger for quakes.
Mm-hmm. Mm-hmm. Very cool.
Basically, anything that's going to disturb the local magnetics, the local geomagnetics, or inverse, which chicken or egg, the local electrical field. Anything that disrupts that is going to have the potential, in my opinion, to release the piezoelectric, the piezo-magnetic buildup.
Right.
And that's what causes this explosion or the earthquake.
We see this type of lag though that occurs, right? As far as its distance from the sun here, right?
Yeah, there's definitely lags. The question is, and it's different ones. So, there's this thought that maybe there's an alpha wave that hits from a coronal hole before really the coronal hole is facing directly at us. So maybe it's going backwards on the return current or something. Hard to say. But so we're looking into that. There's the solar wind itself from CME or the coronal hole. Those always will affect our stability, our global magnetic stability. And what we're curious about is where does it go from there? So we know, globally, all of the magnetometers, depending on which sets you choose, but when there's a geomagnetic storm, basically all are going to say that there's a disruption in the local geomagnetics. So when we say there's a geomagnetic storm, it's basically we're measuring 5 to 20 different stations across the globe and saying, running averages essentially. So to us, it comes down to measuring local geomagnetics and the local fields, assuming that those might be the precursors. I shared a link a little while back. Dr. Love from the U.S.G.S. Did a recent study, I think in Minnesota it was, during a geomagnetic storm, a low one, I think it was a class 2 or something. They were measuring the telluric, or basically the potential, the ground potential, and they saw 2 orders of magnitude deviation within a short period of time during the storm. So we know that it's moving around in the crust, and we want to track that. That's one of the projects that we have on our site. We're working on right now. That'll have a Kickstarter with it, hopefully at some point.
Oh, cool. Okay.
Right on.
Can you give us a shout out for your site and where to find some of your content and material?
Yeah, it's 9rese.org, the number 9 RESE .com. Excuse me, not .org.com. And yeah, we're posting stuff daily, and hopefully those 2 projects, once they come live, there'll be ways to access that. Membership right now is free for a lifetime. Eventually, once some of these things start building up and getting a little bit more traction or go live, we'll be charging. Most likely that'll happen when we start building the wiki, which will be hopefully a very comprehensive community-built Wikipedia of the electric, magnetic, and harmonic universe theories. And
Nice.
Very cool. Very cool.
yeah, it's going to have some interesting power to it. There'll be a really nice mind map, basically, where you can see the interconnectedness between different topics. Our whole focus is to find a way to organize the interdisciplinary thoughts and conversations, knowledge that we're having, and seeing how we can build stuff up. A lot of it, we're talking about similar stuff, but using different terminology or coming from a different angle. And it just takes that one person to crack it for another person.
Right. Exactly. Yeah. Anything we can do to help promote it and get the word out, let us know.
Yeah. No, I mean, just allow me to speak about it on the cast is a pleasure.
Sure. Yeah. Very cool.
I just from someone who's been able to experience the app, I can't wait for it to be public and for other people to get to enjoy it openly and see these things, because it's really great work that you're doing here. It's really necessary, and
it's fun to watch it. It's fun
Yes,
to watch
it
the space weather go from the sun and come in, and and if the sun's quiet, watch the cosmic rays go up. And
can you talk a little bit about this one that's up on the screen right now, the geomagnetic charge map? It was like a prototype, this blue
who's
map where we get the geomagnosphere cut plasma pressures from NOAA.
Okay.
That we're looking at here. No, about that. I'm sorry, right above that.
This one?
Yeah.
Oh, that's the geomagnosphere cut plane. That might be the one that they've changed into the geoelectrical potential, I think is what they're calling it.
Yeah, it's like
we have it there. We have the full US version on the app. Yeah, that's their estimations of basically how the current's going to be flowing through the United States. But it's really low resolution.
Are these like data points here? Or?
No, that's just the grid for their map.
Okay.
No, we don't have that kind of resolution with the data.
So you're measuring what exactly? What's the what behavior are you measuring? Is it potential or?
Well, these ones aren't ours. These are from NOAA.
Okay.
So this one, yeah, I'm not sure. Basically, I assume they're talking pressure, so intensity or strength of the local geomagnetics is what they're trying to estimate based off of what sensors they do have. Most of them are at universities, and there's a few, I think 40 U.S.G.E.S. permanent sites on the continental. Yeah, I think that you said it was an experimental product, and I think now the new experimental product is the geoelectric field model that they have.
So
And really, it's like I say, it's the chicken or the egg. If you can measure one, you can fairly safely estimate the other.
So there's a dark spot there along Appalachia by West Virginia that goes through, and it's consistently dark. Is that on account of there being like lack of meters in that area, or is that a consistently dark area? And if it is, why?
I'm not totally familiar with my geology over there, but don't we go into a different rock structure to rock?
Yeah,
More?
it's all slate. I mean, that's where the coal mines are. It's all slate
Right.
through there. Why I was wondering if that was why it was darker.
No, there's an amazing amount of specialized work on different types of rock and their electrical potential and piezoelectric potential out there, and they all vary. And different pressures, different temperatures, different water content, all of these things, oxidation levels, like that olivine article I posted earlier. They all change these properties, and so. I would say if it's consistent, in these charts, it means that we understand in that area the Earth is reacting different to the changing magnetics and or energy.
That's really interesting because I've been watching. That one was so interesting to me because it was something new. I was like, oh, what's this meter? And so I watch it and it blinks and it blinks and it shows up and it's really cool to watch. But that spot always stays dark and it is a coal mining area. It is somewhere full of slate, and so that's just a question that piqued my interest. And that's another cool thing about being able to look at all these meters all the time because you get to actually visually see the differences occur in real time.
Like that geoelectric one, on around the 30th parallel, there's a very definitive line that shows up during the storms. Where there's something happening where that it just right there at that line. There's a different reading for both electric and magnetic fields. So
interesting.
That is interesting.
Yeah. It's well, to me it makes sense if you look at it. There's that one lady in Australia, her doctorate down there. She discovered she called plasma tubes. A lot of people were like, "Oh, they're Birkeland currents." I'm inclined to think that they're a plasma tube that's associated with the magnetic field, and that it's just an inner ring of magnetism. And so it's got a shorter. It comes out at the 30th degree and goes in at the 30th degree south. And, it's just an arc there, and we have larger ones from the core, probably all the way through. And that's basically how this stuff's getting channeled into the surface. And then once it's in the surface is the real question. Where's it going? How's it mutating? Is it getting stored in certain places? So that's where the Citizen Global Circuit research network that we're building gets involved.
Yeah. So when you do this, you basically you identify like a place where you're very confident in the data feed that you're getting, and then you actually do the data visualization. You build that whole from soup to nuts, the visualization of that data. Is that right?
Eventually. I mean, right now we're just prototyping the devices. So we have a cosmic ray device pretty well done, and we're just looking cost of production for them. The magnetometers, ones we have are really great. We're just trying to resolve a few things, like they're super thermal sensitive, and we're trying to get a more local source for them. But and those are kind of hobby level where anybody can grab them and plant them, install them how they need to be installed, and then get that data stream. That data stream will be available to people to use that are on the platform, and they can visualize it, do what they want to. What we really want to do is get a stream of it from basically Alaska down to the tip of South America, along the fault line.
Wow.
And really see if we can track, if fault lines are a major conduit or not, or major conduits for certain moments and, not for others.
How many sites would you have, or feeds?
As many as we can get. We're gonna put it out there. We'll have a way for people to sponsor. These are kind of pricey units. We're hoping to stay under $250 out the door for each one.
So is this part of the campaign that you would be doing this, and then the
right? Yeah, this would be part of the Kickstarter.
That's very cool. Yeah, that's a very cool idea.
Right now, like I said, we're figuring out the magnetometers and then measuring electric currents and the local electrical field. Those are the next two that we got to figure out. And people can buy each unit individually, is what we're thinking. Kind of build them up over time if they need.
Yeah. Wow. Okay. So very cool. Anything we can do to help? Well, once again, I feel we're naturally symbiotic here. So
no, you guys are going after the same stuff, and once we get our wiki up, hopefully you guys will contribute to that a little bit and double check our work, make sure that we're not misrepresenting anything you guys are saying or leading people astray.
Well,
we can't know everything, We're only two guys.
We tend to be blue sky things and just play with ideas and see what we can find out, and then that's what makes it kind of fun and enjoyable for all, ideally,
Yeah, that's what allows the interdisciplinariness to come out. Try to be like kittens playing with string.
Right.
I'm curious. I have a question. I'm curious if you know much about basalt and like building things with basalt, or heard anything about it.
Building things with basalt? I mean, it's like most any.
Yeah, I guess they're heating it to high temperatures and it becomes super strong. And there's technology that someone from the Suspicious Observers, one of the guys, maybe Jeremy or something, had a talk with Ralph. I think his name was Ralph. But yeah, it was a talk, and they were talking about the magnetic polar reversals, and then in the middle of it, they were talking about basalt as being a building material, a feasible building material.
I mean, I don't know about how feasible it is to heat it up to where you can change its structure to make it stronger or something. Not that it needs to be any much stronger. I mean, it's get chunks of it and mortar it together, and you got yourself a pretty strong structure.
Right.
Yeah, I don't know if there's an end purpose to that, for as like shielding from increased cosmic rays or trying to survive a class 6 or something. I don't know. It's an interesting concept. I mean, I've before my back went out, that's basically what I did, was build houses out of unique stuff. So
nice.
Yeah.
Well,
and I mean, that's to me, that's kind of an underrated topic, is the cosmic ray problem coming about. All indications to me says that needs further consideration by the masses.
Oh yeah.
Wholehearted. Yeah.
Yeah, we talk about it in like every episode.
Yep.
Big topic here.
Yeah. There's a study I again posted on my website. and they were looking at the last major dipole moment and how cosmic rays doubled from today's current readings during that moment, beryllium-10 specifically. That's to me it. I know, especially as observers, we often talk about how that could be genesis for evolution, mass evolution, spontaneous evolution.
Yeah, we were just talking about something similar recently about the high energy spaces being this, on the planet or anywhere else, maybe being the places that have the most diverse life, just the most diverse life. And are these places like the Galapagos Islands and around the equator and areas like that? What is it about the charge of those places that induce more life? I mean, aside from heat and water, I mean, they supply the things that we need for life, but the way that it develops in so many different varieties, what does that?
Yeah, I don't know. I'm fascinated with harmonics and how it orders structure.
Yeah, are you
orders matter?
Yeah, are you familiar with Richard Merrick at all?
Sound familiar.
Interference theory. He's gone very deep into this topic, and I'll shoot you over a link to some of his work. But this is certainly percolating around, like how harmonics can generate different forms, particularly like within an octave, like what happens within an octave versus, just the multiple harmonics. So
yeah, there's some I forget the gentleman's name, way back in the 60s, went really into a beautiful explanation of that. Yeah, and then I wonder, these different energy levels. There's got to be an interplay in the music there.
Mm-hmm.
So one of the meters that you have is the Schumann resonance, and I was showing it to Dave because
we don't have the meter. We just to clarify, we don't have that meter. But we do have it on the app.
Right, on the app.
Yeah,
you had the meter on the app, and it was showing like a blue line that turned into like a white block. Basically, during the electron flux. Is this the electrons bouncing off the moon? I mean, reverberating from the moon? Is that what's affecting the Schumann resonance in this way?
Couldn't tell you. It'd be probably really dependent upon time of day. So
yeah, I kind of
that meter's in Russia, in Moscow.
Okay.
So it's going to be picking up the ionosphere above that area. And I don't know. To me, the resolution or my understanding just isn't great enough to say exactly how the energy travels between the layers.
Okay.
Whether it just passes through, whether it gets trapped, whether it gets blocked. Is it just bulk wherever it hits and it goes through? Do they get funneled to locations? Indications would say that they're getting funneled. At least into regions. So yeah, I mean, it's from there it could just be wiping out the instrument,
Right.
You could have an energy range that exceeded its level,
and then it's just on the ceiling.
Right. Yeah, that's what it looks like to me.
Yeah.
Sorry, I just walked over to the screen.
It looked really intense. That's why I thought to bring it up when you
yeah.
Because I was like, that's a lot of information.
No, when you see those green lines, those pretty consistent green lines, those start moving down.
Okay.
That's basically when we're looking at the ionosphere shrinking or growing.
Uh-huh.
Okay.
And it's natural for it to move a little bit. It's actually kind of a seasonal thing. So. Which makes sense. Like you're asking, you got this mass that's moving around in this plasma, and it's changing its tilt. Things are pushing on the plasma. It's very dynamic up there.
Yeah. It's interesting. These harmonics happen. pretty significant, pretty consistently. These bands here.
Yeah.
Well, and it's equinox today, and so I was wondering, to what degree those types of things, we get exactly half, like we're at a 90-degree angle, right? We get exactly half day and half night. How do those types of things affect the electron, or the I should just say, like, the energy flows coming to us or through us? Is that, like, in any way a rebalancing?
That's very dynamic. So, like, we're coming into a season where solar wind is much more impactful on us.
Mm-hmm.
Just given the orientation of our magnetic field and the way it meets the solar wind. So we tend to see less intense solar wind to give us a little bit more of a geomagnetic response.
Right.
So it's, there's those little things to take into consideration for sure.
I think it would be great to have you on an episode and explain your app on real time, and we could go through it and like the style.
Has anybody experimented with screen sharing on the phone with the Skype?
We've tried unsuccessfully.
I haven't figured that out yet. Yeah, if you know
you may lose me in this process, but let me see what I can do here. You guys go ahead and talk while I.
Oh, sure. Yeah. Mix among yourselves.
Yeah.
So who do we have on now? I'm losing my contact.
I'm here.
Okay.
I'm here.
Ito, are you still here?
Yeah, still here.
Oh, perfect.
I'm here also.
Peter,
Yeah, Peter, how you doing?
Still here as well.
Okay. And we still.
What are we on Neil? Do we have any?
Neil?
And Neil is still MIA, huh?
His picture's there.
See he's smiling in the picture.
Yeah, he's logged in.
I wonder if he's just passed. I'm concerned. Maybe we should call the ambulance or something.
Maybe.
Somebody with his house phone. We know he has a house phone. Someone.
Yeah. I mean, it's interesting because the energy definitely changes because of it within his absence. It's like, oh man, how do we fill in all this space?
Right. We have open air on this segment.
There's too much open air.
No, I think it's been going good. I think you could play it from beginning to end. Every time it's 4 hours, have 4 episodes, each 1 an hour. 4-part.
Yeah, okay. So we got Todd for a second there. Yeah, we saw your video came in.
Oh, was it my face?
Yeah, we saw your face there. Yeah, there he is. You guys seeing that?
Yep, there's your face.
Yeah. There we go. Yeah. All right.
Not a screen.
We met at the conference, I think. Yeah.
Yeah.
Okay. Nice.
Any Mountaineers with smaller birds than that.
So
I have the option.
Okay. Perfect.
Nice to finally meet you, Todd.
Nice to meet you guys.
Yeah. So
yeah, I'll have to figure that out. Maybe I can just I do like a webcam and just kind of hold it over the screen as I go through it.
Okay. So you develop it for like obviously Apple, like the iPhone, and then
Android, Apple, and iPad. Anything Android can do. It.
Do you do it like for like a PC app or like the MacBook or anything?
No. I haven't touched that area.
Okay.
It probably won't. It's just
because of why people are using their phones so much, and yeah.
So here, again, we might lose me, but I'm gonna try. You guys can hear me?
Yeah.
Yes.
Okay.
It's a different mic, we can tell.
Yeah, off the headset there.
Yeah.
Let's try this.
we go.
Wow. Yeah, now it's full screen. Yeah.
That's my house.
The
It's a little remodel.
The beard is awesome. Loving the beard. Yeah.
He can put Russian Orthodox priests to shame with that beard.
It might get washed out with the light, but there we go. Yeah, getting it.
Get kind of a makeshift tripod here.
Yeah, perfect. Nice.
Yeah.
Got it. Except it's like horizontal.
Yeah, right.
That's okay.
Okay, you just cock your head to about like.
We could cock our heads if necessary. So.
Okay.
I can't. I slept funny last night. I got a crink.
Cool.
No, you
Like
can't
a
mail better.
Oh, yeah.
There we go.
All right. Yeah, you get the gist of it there.
Yeah, nice.
Yeah, unfortunately, we don't have a landscape on it, but so this is like the dashboard. This gives you kind of quick specs on, of course, right? Geomagnetism, X-ray, the proton and electron. You can hit these and get the current maps. So right now we're just getting from that's the KP here. So we're just getting from Ghost right now. If there's ACE data, it'll be right below it. You go down, you can get some more specifics on the solar wind, basically angles and phi angles. It's going to be all the, we have a quick glimpse at live, STO 193A, and then the magnetic, that's what this one is, showing large magnetic features on the sun. The auroras, you'll get all of the latest stuff from NOAA, and then the stuff, these are our alerts that we've made off of NOAA's data or NASA's. The settings, that's not what we wanted. These are all the alerts that we have. You can see there's more alerts than on it time really.
Wow.
Give you a lot of ability to focus on what you want to focus on. Under the sun, there's 3 or 4 categories up here: sun, earth, info, and which is your basic app info stuff, and then premium. Well, eventually you'll be able to watch some more video content. You'll be able to build your own dashboard, get some high definition videos. Although you'll see the videos here in a second, they're pretty good already. And if you want to really dive into the charts, you can zoom in on them and see what's happening right now in these moments. There's another quick sun dashboard. Then we get into each individual one. So this is the solar wind from Discover, ACE. You have the integral spiral.
What are those? Just because they catch my eye.
Right. Yeah.
Yeah.
So these are basically the models that we have of the sun. So that interplanetary magnetic field that you were talking about, those are those green waves there.
Okay.
And you'll see if we have anything really. We are the orange, I believe, in this one. No, we're yellow. So yeah, we're over here.
Okay. That's very cool.
Yeah, so you can see there's a little CME there, and so you can see how that's going to be, how they're estimating it's going to be traveling through in space, and it should be meeting us. This is the side view, so this is like looking down on the solar system. This is from the side. And, get a little bit more information that way.
Yeah. So over what period of time is that?
I believe this we have it set for 24 hours, I think, right now.
Okay.
We can change the time. We build some of these. Some of these you can only get as like this one. only comes as a still image. So we collect the image and then we build the movie out of it.
Kind
of the only
Yeah.
place to find that. There's some different stuff.
Just that one is worth the whole app, or worth the price of the whole app.
Yeah.
This is pretty fun here too. You can really zoom in and start looking at some
Yeah. Oh, cool.
somewhat good detail. And you have the whole SDO suite. So any wavelength that you want to look at, you have the hybrids, which I really enjoy. Not that one. This one of my favorites.
Yeah.
So you can use two of them at the same time?
Yeah, they're pre-compiled ones that are already. So this one is 221, 193, and 171 all laid
Oh,
over.
that is so cool.
Yeah, and so you can set these, and it'll remember your thing. There's the Provo suite for backup. It's a different satellite. These are the ones that we can go and do first level for when they get shut down. We need to just fix the speed on that. Those are UV, extreme UV. Right there. The magnetograms. These are really great for watching, like the sunspots. You can see their complexity. If they're kind of stable, just due to their magnetism, or if they're starting to intertwine their magnetics and might get unstable, cause a solar flare.
Wow.
This one, it's good for seeing. It'll be like a black dot that move across, but we haven't had sunspots for a while, so this is what they're kind of modeling. We're going to have the movie of it, but basically the surface magnetism of the sun, what's happening on that level.
Wow. Okay.
This is the Soho, Alaska, so they're blocking out the main sun to see the corona and what's happening. Really watch the plasmas propagate into space off of this from seeing these. And some more magnetic diagrams. Coronal holes. This is our coronal hole program here. And then, we get into the histories, kind of long-term studies that we have on different sunspots, cosmic rays. I'm sure you guys are familiar with Bartol.
That's great.
And then the Earth, we get into our local geomagnetic conditions, the GOES, our local space magnetometer. This is showing the global magnetic flux for the last, I think, 24 hours. You can see up here and down below, pretty stable right now, but when storms come, you'll watch, change color and grow and shrink across the globe. Some of these are models, fairly accurate. This is the latest one that they have of modeling the magnetosphere.
We need to see the top of the screen a little bit. So it's off the. There we go. Yeah, perfect.
See the state there.
Great. Down a little bit. There we go. Perfect.
Yeah. So this one's modeling one of the angles of the magnetosphere. Yeah, it probably helped if I took off my dirty cover too.
Wow, it's really in depth.
It's really awesome.
Yeah. So like I say, this is all cosmic ray data down here. It's Schumann stuff.
Wow.
The Aurora. Movies too. And this is one of the movies that we make.
Wow. So is that current, or is that the?
The last 24 probably.
Wow. So how did?
Not necessarily that bright in those locations. It's just kind of the potential is there.
Okay. So it's measuring potential, or is it measuring what are we measuring?
So what they're saying, probability of visible aurora.
Okay.
I like how the focal point of the auroras is always opposite of where the sun is actually positioned.
Right. Yeah, that's the whole magnetotail that we have, and what they're trying to figure out right now is what they're calling reconnection. That's just their term for making sense of their observations. But really what they're trying to do is define, okay, what is this observation?
Right.
And so that has a lot to do with the energy being transferred between layers. So there's a lot of force in those events.
Yeah.
And then those are the closest lines to ground, essentially, are the ones on the backside where the reconnection, aka reconnection, is. The F2 maps. This is getting into the ionosphere and its different layers. These are the great ones.
That one's smiling at us.
Wow.
So this is, where you see these going. This is the sun tracking.
Wow, that's very cool.
Wow.
So are they split by the equator there?
Yeah, essentially.
Is there an explanation for that?
Kind of. I'm not too familiar with it, but yeah.
Okay. It's very interesting.
To me, it makes sense in a toroidal mindset.
Yeah. Love that one. Yeah.
Another total electron content. The atmosphere, some more Schumann, a little bit analytical version of the Schumann resonance. It's not just one resonance. There's like multiple, as you see here. They're categorized in the Schumann category. There's some other sources. So this is GFC's KP, so the Germany KP. This is Air Force and their KP. And then this is some ham radio stuff.
Cool.
You get the info. Yeah, this is all Ben's work here. So this is his news. We have his how-to series, basically how to watch the sun and understand space weather and how to forecast it yourself. It's pretty easy one. The broad parameters are very easy to understand.
Right.
Easier than your local weather.
Yeah.
And then links to all of the sources. You want to go to it.
It's a great app for someone to just. I always think of like how kids are interpreting the world, etc. But it's like I know from being a kid to begin with. But it's like you give a kid something like this to explore. It's like this is an amazing treasure chest of just opening eyes to what's going on.
Yeah, it is.
No. So yeah, and like I said, there's more feeds that we'd like to put in there.
What's that one that we're looking
at? This is the composite.
Okay.
Of the sun. This is the limb that's coming in, Earth facing disk.
Wow.
It's iron, ultraviolet.
Yeah. It's like they're moving at the different rates. It's different. You can see the different depths, etc. and stuff.
Yeah. There's definitely different depths being represented, and in high definition, it's far better. My webcam and my screen are both insufficient to give you.
Yeah,
and then you dive in. You go to the website.
This way, it's like it's awesome. So.
You get in the website and you download the really high definition versions of these, and And if you got the right screen, man, it's amazing.
Yeah.
Really, really get in and see some really detailed structures and dynamics.
Right. Those even placement. I mean, just at this point in time, those even placement of those sunspots going the little those.
They're
four
like white sunspots, so they're like they're magnetic weak points where like a sunspot may be trying to come out.
Or
a strong spot where it's trying to come out.
Right.
But no, it doesn't have quite enough strength to come out. And those will give us, A and B class X-rays.
Yeah.
Like I don't know if you caught it on the X-ray graph there, but there's always some kind of X-ray noise essentially coming, and they're coming from those little spots essentially.
Right. Looks more and more like Jupiter all the time.
I mean, Jupiter once being a star is not inconceivable to me, or becoming a star again, even. Yeah, the idea that a star that has a stagnant life, I have a hard time accepting it.
Yeah. You don't see no counter rotation particularly.
Right.
Yeah, and you can see down inside those holes. You can see that there's something going on down in there when you look at it, and it's fun to look at them in all the different colors and all of the different aspects to see what's down in those holes, especially when there's a big corona hole like there is in the south right at the moment. I mean, it's not huge, but it's pretty open. You can see in there, like what is underneath the clouds of Jupiter, what are happening between these layers. We can't past this intensity, but when it cools off a little bit, you could get down in there and see, or I don't know.
Apparently, what I heard about the big giant spot, the storm was calming, or it seemed it was shrinking, and instead of they didn't know exactly what was happening. The storm moved vertically up. As it moved vertically up, it shrank the size of the overall shape of the red eye.
Yeah. What's going on with that? That's it's a little. The Heather was sharing that it's breaking up and having all kinds of variation in its past geometry.
Right. Past shapes and things. It seems like, just from looking at it, because NASA has a really cool tool for the Juno mission that you can go and play with their images. Like they send back the images, and then you can filter them, bring things out, and submit them to be posted on their data sheets. It's really cool. And so I've been looking at the red spot for a while, and it seems like the very center of it started to break into a double nuclei, and that didn't actually hasn't happened yet, but it has been changing in consistency and color. And now they're saying, yes, like I heard too, buddy, that it was coming up, that it was like a vortice coming up. But when I was looking at the pictures again, some of them were looking like really down, not just into the red spot itself, but in the other surrounding storms. You could start to actually see down into the depths of these holes, and like what is down underneath, how deep are they, how far down do we have to go before we hit something else. It's just a really exciting time to be here.
Yeah, it's cool to see the patterns too, the L-shaped patterns and like the right angles, like out of nowhere, like, and then all of the coupled vortices. You got the pentagon one, and then you got the 8. Whatever it would be.
Octagonal.
Yeah.
Octagon.
Yeah. Octagonal. Yeah. There's in the north. What is it? The North Pole of Jupiter is a pentagon, and the South Pole is an octagon, and then the I can't remember if it's the North or South Pole of Saturn is a hexagon.
I think it's the North Pole of Saturn.
The North Pole of Saturn, right? And then our South Pole can become a pentagon as well.
Well, also, if you track the auroras after days and weeks, they undulate in I believe a hexagonal formation as they spiral and move around. They have this pulsating hexagon, I believe. When I was watching fast-forwarded footage of as much as we had on this documentary that I've been wanting to talk about the whole entire time, because it wraps up. I mean, I bring it up every once in a while. It's called Space from Above, and it has to do with satellites. We're going to add a link to it here on Becoming Borealis and the U.1. But it's a really good documentary, and it shows the cycles of everything, and it taught me a lot. So I think it would serve us all good to watch this documentary. But anyway,
Okay.
it's on YouTube.
It goes back to that. Oh, sorry.
Go ahead.
The shape, and then the Windershins, or the clockwise, counterclockwise, right hand, left hand rule, and like which way goes to what, and what directions are these things flowing, and then they're flowing in these directions, and their interiors are flowing in these directions, and then they sometimes come out. So that's why it was also interesting what Bruce Leyburn was talking about, how the different magnetic fields will pull each other in weird ways. It's like how do each of these things intersect and correlate to create the shapes? Because I'm really interested in how it seems like these types of shapes keep us in motion. They keep us where we are, placed where we are, and then how we all interact with each other, all of the different parts of the machine, the different cogs of the machine. And so if we can figure out what these like the hexagon, that the hexagon is the shape of beehives, and so many things that just come out in these specific forms. What is it that drives the tendencies toward those particular shapes, right?
I think it's the Merkaba. I mean, it's Merkaba.
Merkaba.
The Merkaba field.
The dual tetrahedron.
Yeah,
right.
The Merkaba fields, but they're nested and nested and nested and nested, and it doesn't have to be hexagonal or tetrahedral or.
That's what I'm asking.
There could be. Yeah.
What specific each of these polygons? Okay, what drives these particular indicators? What drives these particular features? What drives this particular? Why do you know what I mean? What is significant? I mean, I guess that's what we're all been asking for since the beginning of time. What is significant about each of these shapes and their interaction with each other? So if we can look at things that carry these similar shapes throughout and say, what correlates within their function of, within their space, within the whole, or within their space individually, what is it that correlates?
Intervals.
And then
frequency. Yeah, I think.
Why?
That's that Keplerian thing that Bruce was talking about.
But that's so hard, because if you think of it, I mean, I know how, different people have different views on polar configuration, but if there was a solar system aligned in a polar configuration, it might look to us from this distance as it being one planet, right? Because it's just going to blink at the same time every time it passes through consistently. I mean, it might like have a little bit of a draw afterwards, just like, a little bit of an effect, but depending on how big the other planets are, and are they leaving like a slight shadow tail as they move out of the way, and do we have sophisticated enough instruments to detect something like that? So I'm still not like, I mean, the Kepler system's awesome, but it's not enough